Determine whether or not capital F is a conservative vector field. If it is, find a function small f such that capital F is equal to the gradient of small f. In example 1, suppose capital F of xy is equal to xy plus y squared I plus x squared plus 2xyj. So what we're going to do is let p equal to xy plus y squared and q equal to x squared plus 2xy. The partial of p with respect to y is equal to x plus 2y. The partial of q with respect to x is equal to 2x plus 2y. Since the partial of p with respect to y does not equal the partial of q with respect to x, we can say F is not a conservative vector field. And that's example 1. Example 2. Suppose capital F of xy is equal to ye to the xi plus e to the x plus e to the yj. Let p equal ye to the x, and let q equal e to the x plus e to the y. The partial of p with respect to y is equal to e to the x. The partial of q with respect to x is equal to e to the x. Since the partial of p with respect to y is equal to the partial of q with respect to x, F is a conservative vector field. Now we want to find the potential function small f. And here's how it works. Set the partial of f with respect to x equal to ye to the x. Okay. Now we want to find small f of xy. Well, in this situation here, y is held fixed. And so f of xy is equal to ye to the x plus g of y. And from here, we want to take the partial of f with respect to y. Well, the partial of f with respect to y is equal to e to the x plus g prime of y. And we're going to use the second component of this vector field to get a handle on g of y. So from here, set e to the x plus g prime of y equal to e to the x plus e to the y. The e to the x terms cancel, and we have g prime of y is equal to e to the y. So g of y is equal to e to the y plus k. And remember, k is constant. And so therefore, f of xy is equal to ye to the x plus e to the y plus k. And remember, e to the y plus k is another name for g of y. And that's how we do example 2. Let's take a look at example 3. Suppose capital F of xy is equal to y squared cosine of x plus cosine of yi plus 2y sine of x minus x sine y j. Let p equal to y squared cosine x plus cosine y. Let q equal to 2y sine of x minus x sine of y. So the partial of p with respect to y is equal to 2y cosine of x minus sine of y. The partial of q with respect to x is equal to 2y cosine of x minus sine of y. And notice how the partial of p with respect to y is equal to the partial of q with respect to x. So we can say F is a conservative vector field. to find the small function f, in other words, to find the potential function little f, what we're going to do is we're going to set the partial of f with respect to x equal to y squared cosine of x plus cosine of y. And so notice how that's the first component of the vector field. Now, y is fixed. And so f of xy is equal to y squared sine of x plus x cosine of y plus g of y. Now, what we're going to do from here is find the partial of f with respect to y. And that's equal to 2y sine of x minus x sine of y plus g prime of y. And so we're going to set this piece equal to the second component of the vector field, because ultimately we want to get a handle on g of y, just like in the previous example. So we're going to set 2y sine of x minus x sine of y plus g prime of y equal to essentially the second component of the vector field. So in other words, this is equal to 2y sine of x minus x sine of y. So these terms cancel, and so do these terms. And we can say g prime of y equals 0, so g of y equals k. And if we put it all together, we found our potential function. So f of xy, and that's little f of xy, is equal to y squared sine of x plus x cosine of y plus k. And let's take a look at one more example. So we're going to call this example 4. Suppose f of xy equals natural log of y plus y over x I plus natural log of x plus x over y j. And what we're going to do is we're going to let p equal natural log of y plus y over x. And we're going to let q equal natural log of x plus x over y. So the partial of p with respect to y equals 1 over y plus 1 over x. The partial of q with respect to x is equal to 1 over x plus 1 over y. And since the partial of p with respect to y is equal to the partial of q with respect to x, we can say f is a conservative vector field. And remember, we're not done, because now we want to find the potential function little f, right? So to find small f, what we're going to do is we're going to set the partial of f with respect to x equal to the first component of the vector field. So in other words, we're going to set this equal to natural log of y plus y over x. So I want little f of xy. And so I have to integrate this other side with respect to x. So that's what's been going on the whole time. You can think of it as like a partial integral. And so over here we get x natural log of y plus y natural log of x plus g of y. Okay. Remember, y is fixed. It's constant. And if y is fixed, y squared is fixed, sine of y is fixed. So any function of y is essentially fixed. And that's why I add that g of y at the end. So let's rewrite this over here. So f of xy is equal to x times natural log of y plus y times natural log of x plus g of y. So now I need the partial of f with respect to y. So this is x over y plus natural log of x plus g prime of y. Now, remember, ultimately, I need to get a handle on g of y, and I'm going to use the second component of the vector field to accomplish that goal. So, in other words, I'm going to set x over y plus natural log of x plus g prime of y equal to natural log of x plus x over y. That says g prime of y equals 0. So g of y equals k. And I'm done. I found my potential function. So f of xy is x times natural log of y plus y natural log of x plus some constant k. And that's going to conclude this video where we determined whether or not capital F is a conservative vector field. And if it's a conservative vector field, we found a potential function small f, for which the gradient of small f is equal to that vector field, capital F. Okay, thank you.